This is part 1 of 2.4 dealing with the chain rule. The chain rule is going to be used whenever we have a composition, which is basically a function inside of another function. And the rule is as follows. You have a f with g of x inside of it, and that derivative is going to be the derivative of f prime with g of x inside times the derivative of g of x. So basically the derivative of the inside function gets multiplied in the end. And hopefully this will make sense with a few examples. So example number 1 deals with y equal to the square root of x squared minus 3x. And I want to find the derivative of that. And you kind of think of the inside as x squared minus 3x. That's inside a radical. That's what I mean by f and then g. It's inside the radical you have x squared minus 3x. Alright, so for my derivative, it's going to be a y prime equal to. Now all of this is being raised to the 1/2 power. So I'm going to put x squared minus 3x, all being raised to the 1/2. And what the chain rule says is first take the outermost derivative. The outermost is being raised to the 1/2. All this is being raised to the 1/2, so I'm going to do the power rule by raising this to the 1/2. And the power rule says you drop the 1/2 in front and you subtract the power by 1, so it's going to be negative 1/2. And then the chain rule says you keep the inside the same, and the inside being x squared minus 3x. So this stays as x squared minus 3x. And now the chain rule says I have to multiply by the derivative of the inside. And again, we said the inside was x squared minus 3x. So the derivative of x squared minus 3x is basically 2x minus 3. And let's make a little note over here that the reason I got this derivative of x squared minus 3x is power rule says you drop this in front, so 2x to the first power minus 3x to the 0. This is just going to be a 2x, and this is going to be 3. That's how I get this over here. Alright. So that's what my derivative is. Now simplifying this, I can say y prime is, all this is being raised to the negative 1/2. So that means it's going to go in the denominator. So it's going to be 1/2 radical. All this goes inside, squared, minus 3x. And all that's getting multiplied by 2x minus 3. Last thing I can do is just put this in the numerator. So my first derivative is going to equal 2x minus 3 all over 2 radical x squared minus 3x. And that's my derivative for first example. Example number 2 says if f of x is equal to 1 over x squared plus 4x to the third in the denominator plus e to the 2x, I want to find f prime. Again, I want to do a little rewriting before I actually find my derivative, so I can say f prime is equal to the derivative with respect to x of, since all of this is in the denominator, I'm going to bring it up and put it as a negative exponent. So this is all to the negative 3, and this is going to be plus e. Now what's inside of e is the 2x, so I can kind of just write this as 2x. That's going to be two separate chain rules, the chain rule on this one and then a chain rule on this one, because inside of the e, the inside function is 2x. Alright, so now my derivative says the outermost is the power rule of x to the negative 3, so it's going to be negative 3. Subtract the power by 1, so it's going to be negative 4. Inside stays the same. Multiply that by the derivative of the inside now. That's going to be 2x plus 4. And again over here on the side, I can do the derivative of x squared plus 4x to be the power rule, 2x to the first power plus 4x to the 0. And you don't have to do this. every single time, but I'm just showing how I got this derivative, how I got g prime, the inside. Alright, so all this is just the derivative of that. Now, the derivative of this portion is, well, the derivative of e is itself, so you have to recopy e to the 2x. And now multiply that by the derivative of the inside. The inside we said was 2x. So the derivative of this is 2. And again, I can make a little note that the derivative of 2x is just basically 2x to the 0. So it's going to be a 2. That's how this 2 came from the derivative of the inside function. Alright, and then simplifying this some more, I can go only the parentheses being affected by the negative exponent, so only this is going to be in the denominator. So it's going to be x squared plus 4x to the 4th power. It's going to be negative 3. And since this is being multiplied, I can just put it as negative, or as 2x plus 4. And then I can just put this as plus 2 e to the 2x. And that's the derivative for f. Alright, we have one last example. Example 3 is saying let y equal sine of 3x plus 1 over 1 minus 2x. I want to find a tangent line equation at 0 and 1. So the first thing I have to do is find the slope. The way I can find my slope is find out what y prime is equal to. So my derivative is derivative with respect to x. Inside the sine, I have 3x, so I have to use the chain rule on that. And all this is in the denominator, so I'm going to bring this up and write it as a negative exponent, so it's to the negative 1. And then I go ahead and use the derivative rules. Switch this up. So the derivative of sine is cosine. That's going to be the outermost. So the outermost function is sine, so the derivative of sine is cosine. And this inside is the same. Now the derivative of the inside, which was 3x, that derivative is 3. Okay. Now this derivative is, the power rule is the outermost function, so it's negative 1. Subtract the power by 1, so it's negative 2. Keep the inside the same. And now the derivative of this inside is just going to be a negative 2. And again, how I got negative 2 was the derivative of 1 minus 2x. This derivative is a constant, which is 0. This is going to be negative 2 x to the 0, and which just becomes negative 2, which is how I got this. And this looks kind of funky because I have a positive and negative, so this is really just a negative that I have in front. So let's get this out of the way there. I don't want to confuse anybody further. So what all this becomes is 3 cosine of 3x. I'm multiplying a negative times a negative, so it's going to actually turn out to be positive. This parenthesis is being raised to a negative exponent, so it's all going to go in the denominator. So it's 1 minus 2x squared. And that. So that's my derivative. To find the slope, I have to now evaluate the derivative at the point, the x-coordinate, which is 0. So y prime of 0 is going to be a 3 cosine. Well, when I plug in 0 here, it's going to end up being 0 plus 2 over 1 minus 2 times 0 squared. Cosine of 0 is 1, so it's going to be multiplied by 3, so this remains 3 plus, this is going to be 0, 2 over 1 squared remains 2. So my derivative y prime is equal to 5. So it's going to be my slope. And so now my tangent line Tangent line equation is going to be y equal to mx plus b. I know my m is 5, the x-coordinate is 0. I don't know my y-intercept, but I know the y value at the point given is 1. So I know that my y-intercept is 1. So now my tangent line is going to be y equal to 5x plus 1. And that is all for part 1. And I will clarify as much as I can in class tomorrow.